Good evening, children. Hope you are ready with your notebook, scale and pencil, and having the concept of axioms and theorems, right? Let us recall the axioms. So far what we have studied right from axiom 6.1, 6.2, 3 and 4, and theorems from 6.1 to 6.5. Okay? According to axiom 6.1, if a ray stands on a straight line, the sum of the adjacent angles so formed is supplementary, that is 180 degree. Clear? Conversely, if the adjacent angle so formed is 180 degree, then the non-common arms form an opposite rays. They form a straight line. The opposite rays. The non-common arms becomes opposite rays means it is a straight line. Conversely, if it is 180 degree, a ray should lie on the straight line. If a ray lie on the straight line, then the adjacent angle is 180 degree. So 6.1, 6.2 together called as linear pair angles. Okay, sorry children. Yes, those two axioms together called as linear pair axioms. Now coming to axiom 6.3 and 6.4, they are called corresponding angle axioms. That is, if a straight line, if a transversal intersects two parallel lines, then their corresponding angles are equal. Conversely, if the corresponding angles are equal, then the lines are parallel. Based on that, we are going to prove some theorems. Axioms are true statement without proof. Using the statement of the axiom, we are going to prove the theorems. The first theorem states when two lines intersect at a point, the angles so formed, what we call those angles? When two lines intersect, the angles so formed are what we say, those angles which form when two lines intersect. When two lines are intersect, the angles so formed, what we call those angles? They are vertically opposite angles. They are equal. We have proved that. When two lines intersect, the angles vertically opposite angles, it's not adjacent angles, they are vertically opposite angles, they are equal. That is theorem 6.1. Aishani, they are not adjacent angles, they are vertically opposite angles. That is, when two lines intersect at a point, then the angles so formed, these are the pair of angles They are vertically opposite angles. According to theorem 6.1, we proved this. Okay. Next, theorem 6.2. If two parallel lines intersected by a transversal, then the pair of alternate interior angles are equal. We have proved this using corresponding angle axiom. Right? They are the pair of, that is, angle 1 equals angle 2, angle 3 equals angle 4. They are the pair of corresponding angles. Alternate interior angles. We prove using corresponding angle concept. I think you all practiced it. Is clear? Have you all practiced it? So on Sunday class, in the interaction class, all the theorems and axioms you should write up in the sheet or book. When I call one by one, you have to show the axioms and you have to read out the axioms. I may call anybody. Is it clear? Sunday you have to get ready with this. It is between 4 to 5. You have to write up all the axioms, all the theorems, and the name who I call, you have to show that, as well as you have to read out that. I may ask a question regarding that lines and angles chapter. Okay. Now, axiom 6.3 is, if a pair of alternate interior angles are equal, then the lines are parallel. That is the converse of theorem 6.2. That is, if a pair of alternate interior angles are equal, then AB parallel to CD. Theorem 6.2 represents, if a pair of parallel lines are intersected by a transversal, then their alternate interior angles are equal. Conversely, if their alternate interior angles are equal, the lines must be parallel. Okay, now next, this is theorem 6.1. 6.2, 6.3, we can go with this figure. Then 6.4, again we go with, if a pair of parallel lines are intersected by a transversal, then the sum of co-interior angles on the same side of the transversal is supplementary. AB and CD are two parallel lines intersected by a transversal PX at Q and R. We have to prove the sum of the co-interior angles on the same side of the transversal is supplementary. Supplementary means angle 1 plus angle 2 equals 180 degree. Its converse, if the sum of co-interior angles is supplementary, then the lines are parallel. I have given the best example about your studies. If you study well, you can get the marks. If you got the good marks, that means you have studied well. Like that, if the lines are parallel, co-interior angles are supplementary. Conversely, if the sum of co-interior angles are supplementary, the line must be parallel. Is it clear? And 6.1, 2, 3, 4, 5. One more theorem is there regarding this parallel line, that is, lines parallel to the same line or parallel to each other. That is regarding theorem 6.6. Write the heading as theorem 6.6. Then take the statement. So far I just recalled this geometry portion. What theorem and axioms you have considered and viewed, and I think I had given the home assignment that you have to repeat all the theorem statement. Only 8 students, not more than 8 students information I got it, the recorded. Remaining they kept quiet. I should call, they are thinking that I should call everybody's name. Don't think that. Whenever the homework is assigned, you have to do. Okay? Sometime I'll get immediately after the test the response. Such a very enthusiastic students also there and lethargic students are also there. And I want to clarify whose name is ERA, ERA, because every time the ERA got very less marks. I couldn't note, record that whose name is that ERA, ERA. Could you give me the answer? Who is under the email ID ERA, ERA? Have you all observed that? No. The ERA is not here in the class today. Okay, thinking that I will continue. Theorem. Yes, you just see the last class video what I given the instruction, follow the instruction. Okay. Now write the heading theorem 6.6 and write the statement under that. Lines which are parallel to the same line or parallel to each other. Theorem 6.6. Take the theorem 6.6. Lines which are parallel to, which is parallel to, no, lines which are parallel to the same line, lines which are parallel to the same line or parallel to each other. Take the statement and below the statement get the figure. Draw 3 lines. Draw 3 parallel lines and below the parallel lines get a transversal which intersects these 3 parallel lines. PS, you can name it as I am searching the textbook figure, I couldn't get. L, M, N. These angles letters are not necessary. Just you can consider lines L, M and N intersected by a transversal PQ at A, B, C. Here, line L is parallel to M. Line N is parallel to M. So, we have to prove L is parallel to N. Okay? When line L is parallel to M, then their corresponding angles are equal. That is, angle 1 equals angle 2. And when line N is parallel to M, then angle 2 equals angle 3. From the result, we can obtain angle 1 equals angle 3. According to axiom 6.4, the lines are parallel. If this line is parallel to M, this line is parallel to M, then these two are parallel to each other. Lines which are parallel to the same line are parallel to each other. Clear? Get the figure? For the theorem, we require all the steps that is given to prove proof. Here, no construction. Okay, na? Shall we start the steps here? Given line L is parallel to line M and line N is parallel to line M. L is parallel to M, N is parallel to M. To prove line L is parallel to line N, we have to prove these two are parallel. When they are parallel to the same line, they are parallel to each other. Okay, na? Line L, M, N. You can also take L is parallel to M, N is parallel to M. Then they are parallel. Lines which are parallel to the same line or parallel to each other. To prove also over, now we will come to the next step, that is proof. Since line L is parallel to line M, line L is parallel to M, therefore angle 1 equals angle 2, axiom 6.3. According to axiom 6.3, when the lines are parallel, their corresponding angles are equal. Take it as the result 1. Next, since line N is parallel to line M, therefore angle 3 equals angle 2. Same reason, axiom 6.3, result 2. In result 1, we have taken angle 1 equals angle 2. In the result 2, we have taken angle 3 equals angle 2. Which is the common angle here? Angle 2. Therefore, from the result 1 and 2, we get angle 1 equals angle 3. Angle 1 equals angle 3. But these are pair of corresponding angles. Corresponding angles. Therefore, line L is parallel to line M. Bracket axiom 6.4. According to axiom 6.4, if the corresponding angles are equal, the lines are parallel. According to axiom 6.3, if the lines are parallel, their corresponding angles are equal. We are using axiom 6.3 as well as 6.4 to prove this theorem. Which is the theorem? Lines which are parallel to the same line are parallel to each other. Repeat the statement because we are going to apply these properties of the condition for the proof of the next type of questions. We call it as riders based on the problems based on the theorem statement. Okay, na? Is it clear to everybody? See the question. The statement is these lines are parallel to the same line. So we have proved they are parallel to each other. Okay. Is it clear to everybody? Next. We have the problems based on the theorem. So far we did many theorem 6.1 to theorem 6.6. We have many problems based on that. Now we have the problems. Okay. First question in figure. Take the first question. This assignment worksheet I have not sent. Okay, you take the question in figure. Yes, line L is parallel to line M. Find X. I think this worksheet I have sent. Take the figure. Now, with all the theorems proof, I hope it is possible for you to answer this. Here it is given X and this is 44 degree. Name it as AB and CD. PQ. What we call those angles? The lines are parallel, so what we call angle BPQ and angle DQP. What are the angles called? They are co-interior angles. Sum of the co-interior angles is supplementary. We have proved. So using that we can go with the answer. Since L is parallel to M, therefore angle BPQ plus angle PQD equals 180. Write the reason. Sum of co-interior angles. Sum of co-interior angles. Now it is clear. We can apply the values there. What value will get? After showing the sum of co-interior angles, therefore X plus 44 degree equals 180 degree. Therefore X equals, find the answer. (180 minus 44 degree) 136 degree. Correct? We got the answer under the property sum of co-interior angles is supplementary. You have to write the reason here or else you can mention the theorem. Theorem's number if you are not able to find or remind, you can give the property which satisfies to find out the value of x. Shall I move on to the next question? It is given. This is the figure. Take the figure which I sent already. Here AB is parallel to CD. Angle APQ is 60 degree. APQ. degree. Angle PRD is 137 degree. Find x and y. So this is the question we are answering before having the theorem angle sum property. Once you know the angle sum property concept, based on that you can easily solve this. Now we are having the problems based on the parallel lines and the transversal. So according to that we have to prove now. After getting the theorem confirmed, then you can apply angle sum property also. I will teach you later. That is theorem 6.7. Okay. What the figure? Here it is given. AB is parallel to CD. In the bracket you write given. AB is parallel to CD. This will act as a transversal. Therefore, angle APQ equals angle PQR. In the bracket you write alternate interior angles. Alternate interior angles. And we have proved that if two parallel lines are intersected by a transversal, their alternate interior angles is equal. Therefore, 60 degree equals x. X value is 60 degree. Okay. So now, again this will act as a alternate interior angles. Similarly, I will use this symbol. Similarly, angle APR equals angle PRD, since AB parallel to CD. See, these two are parallel. This is a transversal. So this whole angle equal to this. APR. We can write APR as 60 degree plus y equals 137 degree. Therefore, y equals 137 minus 60 degree. Y equals 13 minus 6. It is 7. 13 minus 6 is 7. So y equals 77 degree, x equals 60 degree. Grishma, it's clear now? You gave the answer as 120 degree. So just to see whether they are co-interior angles, alternate interior angles, corresponding angle. Check it, observe, and then write the answer along with the reason why it is. I written the reason here. We have considered these two angles are equal because the lines are parallel. Here they are given, they are parallel, therefore they form alternate interior angles. Like that, for every answer you have to give whether it is given, whether it is satisfy any property, you have to give up, then you have to proceed. Okay? Geometry is full of reasoning. Is it clear? So don't directly go with the final answer. You have to mention AB is parallel. That is the reason we have considered they are equal. When they are equal, x equals 60 degree. Like that, give the reason, then get your answer. Is it clear to everybody? Next question. Shall I move on to next question? In figure, it is not given A separately, like this only it is given. Take it like this. A, it is B, and this is C and D. Point P, they have given it is X. It is 104 degree, and here it is 116 degree. Get the figure, please. It is given AB parallel to CD. Find the value of X. Take down the figure using scale and pencil in proper way. Either you can write the figure in the right side of your book or in the left side. Don't mix up figure with your answer. Show the answer in very neat form. Okay? To this, one construction is needed. I will do the construction. This is the construction you have to do. Passing through the point P, draw a line MN. Passing through and mark this angle 1 and this is 2. That is angle APN 1, angle CPN 2. For this construction is required. With the construction, we can bifurcate two set of parallel lines, applying the property lines which are parallel to the same line or parallel to each other. That is, we drawn MN parallel to AB, but AB parallel to CD. Therefore, MN is also parallel to CD. Lines which are parallel to the same line or parallel to each other. So before starting, you have to write construction required here. Construction through point P, draw MN parallel to AB. Proof. AB parallel to CD given. MN parallel to AB is also, it is by construction, right? AB parallel to CD is given in the question. By construction, we did MN parallel to AB. Therefore, what we can say? MN parallel to CD. According to theorem 6.6, lines which are parallel to the same line or parallel to each other. Okay, now since AB parallel to MN, therefore angle 1 plus 104 degree equals 180 degree. Angle 1 plus 104 equals 180 degree. What is the reason? Angle 1 plus 104 degree equals 180 degree. What is the reason? You have to write in the bracket. They are what they are? Yes, co-interior angles. Good. They are co-interior angles. Therefore, angle 1 equals 180 degree minus 104 degree. Angle 1 equals 76 degree. Okay, na? Similarly, you have other part. Which is other part we can consider? Which is the other part? Since MN is parallel to CD, angle 2 plus 116 degree equals 180 degree. Write the reason. Co-interior angles. Therefore, angle 2 equals 180 degree minus 116 degree. Angle 2 equals 10 minus 4. 10 minus 6 is 4. Then 7 minus 1 is 6. 64 degree. Okay, na? We require x. X is sum of angle 1 and angle 2. Therefore, angle x equals angle 1 plus angle 2. Angle x equals 76 degree plus 64 degree. X equals 140 degree. So in this figure they are given in both the condition it is co-interior angles only. Some problem you may get one pair as alternate, another pair as co-interior. For the co-interior angle we have to subtract it from 180 degree. For alternate you have to take as it is. So here in this figure you have both the angles satisfying co-interior angles only. Okay, same type of question I will continue now. Is it clear to everybody? Clear? Any doubt regarding? Or you want to repeat this? I will do that also. Here I did the construction. The line MN is parallel to AB. But AB is parallel to CD. MN is parallel to AB. So it is also parallel to this. Lines which are parallel to the same line are parallel to each other. Okay, na? Shall I proceed to the next question then? Everybody is clear? Have you all doing the figure with scale and pencil? Because figure should be perfect, then only you can go through this. Now at present you are able to understand. After 15 days if you open it, without the proper figure and the mentioned angles clearly, is not possible to recall. So take your work as neatly as possible. Is Adya is present in the class today? Adya from Excel or NPS? Adya. Oh, thank God Punya is present today. Welcome to the class, Punya. Adya, what about Adya? Yes, she is from NPS. Okay, are you answering? You are taking the notes? Are you taking the notes? Adya? Okay. Yes, Punya, be regular to the class. Okay. What about Maulya TR? Maulya from Jesus, Maulya from St. Joseph. Are they present? Maulya, Maulya TR. Aishat Hanan present. Is Aishat Hanan is here? Yashas from St. Joseph. Yes, Yashas from St. Joseph. Not DMS. St. Joseph boy. Yashas. Next question. Find the angle, measure of angle XMY. In textbook it is a example question. It's a very important question. Same type of figure, but here instead of both the angles co-interior, they are taken one set as co-interior, another set as alternate interior angles. Please take the figure. Question is not in your worksheet and write the question. Okay, it's not in your worksheet, but it is a textbook example question. And write the question also. You can take the question in figure. PQ parallel to RS. If PQ is parallel to RS, angle MXQ equals 135 degree, angle MYR equals 40 degree. Find angle XMY. Find angle XMY. Figure. PQ is parallel to RS, XMY, where MXQ is 135 degree, MYR is 40 degree. Have you all noticed? In this case, the angles are not in the same side of the transversal. One is in the opposite side of the transversal. Here it is the same side of the transversal. For this question also, we require a construction part. Draw a line passing through the point parallel to PQ. I will name this line as AB. And name these angles as 1 and this is angle 2. So clearly note down. Clear? You have to find out angle XMY. To To this also construction required. What construction? Through point M, draw AB parallel to PQ. So passing through the point M, draw AB parallel to PQ. AB parallel to PQ, AB parallel to, PQ parallel to RS. Therefore, what we can write? AB parallel to RS. Theorem 6.6. Line which are parallel to the same line or parallel to each other. AB parallel to PQ. Again, PQ parallel to RS. Therefore, AB is parallel to RS. One set is given, another set by construction. So, we prove all the three lines are parallel, which implies PQ parallel to AB parallel to RS. All the three lines are parallel to each other. Okay. Next, we do the proof of this problem. Proof. PQ is parallel to AB. Therefore, angle 1 plus 135 degree equals 180 degree. Reason, co-interior angles. Therefore, angle 1 equals 180 minus 135 degree. Angle 1 equals 45 degree. This is first part. Like previous problem, using co-interior angle condition, we calculated angle 1. Now we require angle 2. To that, here they are alternate interior, not on the same side, alternate interior angles. Next, right here, AB is parallel to RS. Therefore, angle 2 equals 40 degree alternate interior angles. Alternate interior angles. You may also mention the angle letter, that is angle RYM equals angle BMY. You can also use the letter to mention. Okay. Now, angle XMY. We require this angle. This is the sum of angle 1 and angle 2. It is 45 degree plus 40 degree equals 85 degree. So many times I will repeat, unless the explanation got over, don't give wrong answers here. Try to listen the explanation. Try to understand the concept. 100 times I repeated, Yashas, he is doing the same thing. I will be removed from the group. If you do like that, I will remove from the group. So because once you give the answer, the others will get the temptation of seeing the answer without listening this. So getting one pair as co-interior angle, another pair as alternate interior angles here. In the previous problem, the figure was like this only, but in both the cases, we used to apply co-interior angle property. Okay? So, you have to see whether it is satisfying corresponding angle, alternate interior angle, co-interior angle, then only you have to proceed. That is the reason Listening of the explanation, observation is very, very important. Later, you can solve 100 problems. First, try to understand the basic concept. Okay, na? Next question. In figure, next question. Take the question, then figure. In figure, PQ is parallel to ST. Angle PQR equals 110 degree and angle RST equals 130 degree. Find angle QRS. QRS. Take the figure. PQ is parallel to ST. Angle PQR equals 110 degree. Angle RST 130 degree. Find angle QRS. Here also you require one construction. Do the construction using dotted line like this. Name it as MN or AB. Check the figure properly. I hope it is clear to everybody. Dotted line shows that we have done construction to get the result. Some problem require construction. So you may put the question, how we know that why you have to do the construction? By practice only. By observing the figure and by seeing what is given, what is required, you can have the construction part. Okay, na? So after this, after putting the dotted line, we can easily notice angle TSR, SRB, they form co-interior angles. So 130 degree plus 1 equals 180, angle 1 equals 50 degree. Okay? Before that, ST parallel to AB we have to prove. That is PQ parallel to ST and ST is parallel to AB. PQ is parallel to AB, PQ is parallel to ST. So ST is parallel to AB. Once they are parallel, then only we can apply co-interior angle property. And here PQ is parallel to AB. They form alternate interior angle. That is angle PQR equals angle QRB. But angle 1 we got with this result. Subtracting, you will will get angle QRS. I will name this as angle 2 so that your calculation will be easier. Okay, na? Taken the figure. Now you write heading with the construction through point R, draw AB parallel to PQ. Now proof part. So we did the construction by drawing a line parallel to PQ. Now PQ parallel to ST is given and AB is parallel to PQ. This is by construction. Therefore, what we can say, ST is parallel to AB, theorem 6.6. Lines which are parallel to the same line or parallel to each other. PQ parallel to ST, PQ parallel to AB, so they are parallel to each other. Now, since ST is parallel to AB, angle TSR plus angle SRB equals 180 degree. So what I said, you can use the letter, that is the part I am doing here. Reason here, it is co-interior angles. That is TSR is 130 degree and we have considered this as angle 1 equals 180 degree. Therefore, angle 1 equals 50 degree. Underline using scale and pencil one stage of the answer. Now again, PQ is parallel to AB. Therefore, angle PQR equals angle QRB. Reason, alternate interior angles. Alternate interior angles. Clear? When alternate interior angles are given equal, so we can say that 110 degree equals angle 1 plus angle 2. Therefore, angle 2 equals 110 degree minus 50 degree. Why 50 degree? Because angle 1 has the value 50. Therefore, angle 2 equals 60 degree. Angle 2 is nothing but angle QRS. Therefore, angle QRS equals 60 degree. That is the required answer. Clear? Is it clear to everybody? Over. Next question. In figure, find the values of x and Next question. In figure, find the values of x and y. Then show that find x and y. Then show that AB parallel to CD. So here in the beginning we cannot consider the lines are parallel. After getting the measure of x and y by the converse of corresponding angle axiom, we can show that lines are parallel. Now in the beginning we are not considering lines are parallel, okay, but we consider in the figure they are parallel. But unless it is mentioned the lines are parallel, we cannot apply corresponding angle, co-interior angle or alternate interior angles property. We can use only linear pair angles, vertically opposite angles only. Okay na? Unless the lines are parallel is mentioned in the figure, in the question, then only we can consider. After showing the values by the converse, we can say that the lines are parallel. Get the figure? It is here 50 degree and this is x and here it is y and this is 130 degree. Take the figure. So directly we cannot say it is a corresponding angle, it is alternate interior angle because the lines are not parallel. I am repeating this because most of the time the students will go with directly x equals y. X equals y only when the lines are parallel. Here we have to show how x equals y. Is it clear? So in the beginning they are not given AB is parallel to CD. We need to show that AB is parallel to CD. To that condition, now here x degree plus 50 degree equals 180 degree. Reason linear pair angles. Therefore, x equals 130 degree. Okay, next y equals 130 degree. Reason vertically opposite angles. Opposite angles. So don't go directly with alternate or co-interior angle. We have to show either using linear pair or vertically opposite angle. Therefore, y is equal to 130 degree. Since x equals y equals 130 degree, they are what they are? They are pair of, what do we call those angles? Angle x, angle y. They are they are alternate interior angles. Pair of alternate interior angles. Therefore, AB is parallel to CD, axiom 6.4. According to axiom 6.4, if the alternate interior angles are equal, the lines are parallel. It's not axiom, it is theorem 6.4. Because 6.1 is vertically opposite, 6.2 alternate, 6.3 theorem. Don't confuse. Theorem 6.3. Axiom 6.4 is recording corresponding angles. Here they are alternate interior angles.